Hello there and welcome to this online lesson today. What you need to do before we get going with the lesson is go onto Google Classroom and load up the Google Doc you can see on there, which is called Computer Systems, and put today's title, which is using a computer, today's date, and then have a go at that starter activity. Give the video a pause and then once you've completed the starter, we'll get going. So first thing we're going to be thinking about is data and information. Data and information are not the same thing. Data is information which has got no meaning, it's got no context. So for example, the number 32, it's just a piece of data. You don't know what that 32 relates to. You don't know what it's for, what it's assigned to. Whereas if we said 32 goals or 32 matches played, that then has become information. It becomes information when it's been given meaning. So you know what it is, what we are talking about. Computers are machines that handle and process data. So the computer doesn't mind or need to know what it is, how it is, what it's working for, what it's doing. The computer doesn't need to know that. It just handles and processes the data. So the data gets inputted into the computer, which is then converted into binary so that the computer can process it in the CPU. We'll look at that later on down the line. The computer processes it so it could change something, it could add something, it could average something, it could modify or delete something, and then that information then gets outputted on the screen for you to be able to see. And remember, we use binary because that's the lowest level of information storage. It's electrical impulses representing ones and zeros. So that's what we're using it for. So data gets stored in bytes in electrical circuits, and bytes are used binary with 1 and 0, so 1 representing on, 1 being off, so then we can know and understand what's there. And then we can use these binary codes to create words, to create images, to create sounds, and we'll look at that later on down the line, but all we need to be happy with right now is that data gets stored in bytes as binary code, and then that binary code can then be looked at and accessed in various ways or forms, most notably with the CPU. So here is the first series of questions you need to do. First, we'll pick if you're going for all, most, or some, and write that down in your Google Doc in big capital letters, and then answer the 2 questions that you're choosing based on the learning outcome. So give the video a quick pause, and then we will move on. So now we want to think about computers working. We've looked before about inputs and outputs, the input coming in and processing, but we need to remember that when we think of a computer, we don't just think of a laptop or a desktop. The computers come in all shapes and sizes. So for example, smartphones contain computers, supercomputers for scientific researches, dedicated computers which can complete tasks such as in a tumble dryer, in a dishwasher, in a microwave, in a TV. All these computers are everywhere. And by using these computers and thinking about how they process the inputs that come in and then how we see those as outputs is key. It's really, really, really important. We need to be understanding and aware that computers don't just have a keyboard and mouse. They can have buttons on the side. They can have buttons, for example, on a dishwasher, which tells you the temperature that the water's going to run at, or the speed, or the cycle of it, or how quickly it's going to be doing it. If it's a fast rinse or a slow rinse, these are all still valid computers. So we've thought about hardware in terms of computers. What I want you to think about with this one is thinking about the internal hardware, the hardware which you might find inside a computer, and the external hardware, things you'd find outside of the case. So for this one, you might want to do a little bit of research, thinking about internal hardware and external hardware. And then what we're going to do after this bit, we're going to go into a little bit more depth. So if you're not sure, keep watching the video to get some ideas of some sorts of inputs and outputs that we're going to be looking at, and you can come back and answer this question. So give the video a pause, give the question a go, and then we'll move on. So we're just going to think about input. Inputs allows devices to interact with the computer system. It can add information in. It can be information in. 2 most common input devices that you're aware of, mouse and keyboard. So for example, a mouse moving a pointer on the screen that you can see moving around now quite happily. What happens on the mouse, there's a little sensor in there which tells the computer the mouse is moving. And when I'm moving the mouse, the sensor is saying, oh look, I'm on the move, I'm moving about. And then that information then gets fed back to the computer. Most mice have 2 buttons on the top, a left click and a right click, some have got middle click. For example, the mouse that I'm using at the moment, my gaming mouse, has got a left click, a right click, a middle click, 2 scroll wheels, and it's got 12 separate buttons on the left hand side, because obviously I do a lot of gaming, I want to be able to assign different commands to each of the buttons. If we're thinking about the keyboard, keyboards are used for sending in letters, typing in commands into a computer, and what happens, each letter is connected to a switch, each key is connected to a switch, and then with that, when that button gets pressed, the command gets sent through. We can also think about touchscreen devices as well. So for example, laptops and tablets having touchscreen devices. These are really helpful. All phones now, pretty much all phones, have got some form of touchscreen device on there. You can also get graphics tablets which have got a stylus which allow you to draw freehand, but then it appear magically on the computer, which can be really helpful for graphic artists, people developing in cartoons. Some different businesses have got different sorts of keyboards altogether. So for example, if you went to Pizza Hut, they might have a keyboard which has got specifically a button on it which says Margarita Pizza, and then that sends in all the commands to their system to know that a Margarita Pizza has been ordered. So what keyboards, mice, touchscreen displays do is that they can turn information into data. So for example, microphones recording sounds, cameras capturing images, webcams and scanners looking at images, looking at pictures. It can take information and then turn it into digital data, something which then the computer can process and can work with. Input devices are used everywhere, all over the place. They're used in shops. You can have barcode scanners, chip and pin machines. Now, as they're becoming more developed, NFCs or near field communication readers allow tap and go so you don't have to enter a PIN code or swipe your debit card. Sensors, which can be used to change environment, so looking at light levels, temperature levels, volumes of noises, look at movements or heats, and security alarm systems. So inputs can be found everywhere. They can identify identities of users. So fingerprint scanners on mobile phones, you can put your fingerprint on there and then it can see who it is it's using, and if it's an authorized user, they can then let you in. Retina scanners to be looking at the blood vessels in the user's eye, again, can be used for security. And then we're thinking about assistive technology as well. So people who have got some form of disability to have better access to computers. So for example, Braille keyboards, which looks like a normal keyboard but with raised dots, so people who are blind knows what each letters are by feeling. You can get mice which are designed to be used by feet rather than hands. Microphones for voice commands. Some devices can track user eye movements. So there's a whole range of assistive technology that can be used to allow users which have got particular disabilities ways to access computers as anybody else. So what we're going to do now, you're going to pick either the almost or some. Again, write that out for me for which one you're going for. Answer the questions, give the video a pause, and then we'll move on. So now we are going to be looking at output. Output, strangely enough, are the devices returned for viewing things that get processed, viewing commands, or scanning something out of a computer system, hence the name output. So once computers process the data, it needs a way of returning that data to the user. That's where we come in with output. So for example, monitors or display devices or TVs are a common way of doing this, and it shows what the computer is looking at visually. So you as a human being wouldn't understand where the data is, what's going on, where it's stored, all the processes happening. But when you see something, so for example, this video you're looking at now, you can understand and you can see what's going on. Touch screens, as I said before, they also do this really, really well. And you can also have projectors as well. So for example, in classrooms, the projectors projecting the information onto a board. Printers can be used to create physical copies of information, physical outputs. So for example, you've got laser prints which can make lots of printouts quickly, but they can be quite expensive. Or you've got inkjet printers which are cheaper to buy, can print fairly quickly, but they can be more expensive. You've got 3D printers like the ones we've got at school at the moment, which use plastics or metals to create 3D models. They can also be used in t-shirt printing or clothing printing, but again, those can get expensive to run and maintain. If we're thinking about other output devices, so buzzers and speakers output sound. So at the moment, you're listening to my voice through either headsets, some headphones, speakers, if you are, hello. And they're outputting a digital signal, so the computer is understanding the digital signal and then outputting it in a way that you can work with. You can then have actuators, which can be made to move. So an actuator is an output device that moves when it receives some form of some sort of signal from a computer. So, for example, motors are a form of actuator that are powered by electricity. Other actuators can be used in machinery to lift heavy objects, such as robotic arms. And then these can be used, of course, to create cars and electronics quicker and more accurately than human. And again, if we're thinking about assistive technologies, they can be used for outputs as well. So some operating systems, such as Windows, allow you to monitor the display monitor so you can see what's going on, so increasing the text, the icon size, the colors to make things stand out more. You can get screen readers, which essentially is clues in the name, which read out the information on the screen so you can see what's going on, you can understand what's being said. And again, that can be output in a special monitor on a braille display, so it can the braille reader can feel the letters on the braille display and read and understand what's on the screen. And you can automatic captioning software. So, for example, YouTube has got this built in now with the videos that get uploaded, including this one, which listens to the speech and attempts it to turn it into subtitles straight away. Sometimes it's not entirely accurate. So, for example, people's accents or languages, it might not pick it up correctly. But there we go. Output is just as important as input. So all you need to do now to finish off what we're looking at in today's lesson is go for your almost and sum to pick the challenge you're doing, and remember to write the almost or sum on your Google Doc. And then once you finish that, think back to what you wrote down at the start. If the starter activity for the lesson was to writing down what hardware you use, have a look again at that hardware. Is it used for input, output? Is it for both? How helpful is it? How could you convert it into an assistive technology? How could you improve it as an assistive technology? Once you're all done, don't forget to click hand in on Google Classroom, and I shall see you for another lesson later. Bye bye.